All right, let's take a look at a couple examples where we have to subtract the area of one portion from the entire shape in order to find the area of the shaded region. All right, so here we have an example of a shape that looks kind of like an envelope. So we want to find the area of the blue shaded region here. So we don't want to include the area that the flap of the envelope takes up, just the main part of the envelope there. All right, so obviously the envelope is in the shape of a rectangle, right? And then the flap is in the shape of a triangle. So if we find the area of the entire rectangle, then we subtract out the part that we don't want, which is this triangular flap, then that'll leave us with the area of the shaded region that we're looking for. All right, so let's go through and do that. So first let's start with the area of the entire envelope. All right, it's in the shape of a rectangle. We've got a dimension of 18 by 36. So area of the rectangle is going to equal 18 times 36, right? Length times width. So that's going to be equal to 648 square units. Okay, so there's the area of the entire rectangle. Now we need to subtract out the part that we don't want, all right? So we've got a triangle here, and we know that the envelope's a rectangle, so if this side is 36, then that means that side is 36. So that can act as the base of our rectangle, and then they give us the height, which is the perpendicular distance from that base to the opposite vertex. That has a length of 9, okay? So area for the triangle, we'll do that in a different color. So that is going to be 1/2 base times height. So the base is 36 and the height is 9. All right, so I'm going to put that into my calculator, and that'll end up giving me a value of 162 square units. All right, so now I want to exclude that triangular shaped portion from the whole thing, and that'll leave me what's left. So my final calculation is going to be to find the area of the shaded region, which is simply going to be the area of the hole minus the area of the triangle. Okay, so that's going to be 648 minus 162, and that'll give me an ending area of 486 square units. All right, next up we have a shape here that looks similar to, let's say, a basketball court. All right, and they want the area of the shaded region. All right, and that's the area that I shaded in red here. All right, so similar to the last problem, we want to find the area of the entire shape, and then we want to subtract out the parts that we don't want from that shape. All right, so as we see, if we close off those ends there, then we're going to create a rectangle that has dimensions of 33 feet by 16 feet. All right, and then we want to take out these half circle shapes here. Okay, so let's go through and do that. So first of all, let's find the area of the entire shape. All right, now so that's going to be rectangle length times width. So 33 times 16, that's going to give us 528 square feet. Okay, and then the parts that we don't want, which is the circles, all right, we'll do those in blue. All right, they're half circles. All right, they're both the same size, so we can treat it just as one circle because we're going to cut it in half and then multiply it by 2 again. So we might as well just treat it as one big circle, just that it's split in half, all right, since we need both halves. So the diameter of the circle here is going to be the same as the width of the rectangle. That's 16 feet. So I want the radius is half that, so the radius is going to be equal to 8. So the area of a circle, remember, is pi r squared. So I'm going to plug in the radius, not the diameter. Okay, so I'm going to do 8 squared times pi. So 8 squared is 64, and then I'm going to multiply that times pi, and that's going to give me an approximate, if I round it off, 201 0.1 square feet. All right, so I'm rounding that off to 1 decimal place. All right, so now I want the area of the shaded region. All right, so we'll do that in red. So again, I'm going to take the area of the entire shape, which was the 528, and then I'm going to subtract out the area of the 2 half circles, which was the 201.1. All right, so I'm going to do 528 minus 201.1 in my calculator, and that's going to give me an ending result of 326.9 square feet. All right, so let's take a look at a real world problem here. A little bit more complicated than the ones that we did before, but I want to try and challenge you a little bit. All right, so take a look at this diagram here. So let's say we have a circular shaped garden area that we want to create in our backyard. All right, and we want a square shaped patio in the middle of it surrounded by grass and plants. So that is the green shaded area around the outside. So what we want to find out is how much grass and foliage do we need in order to fill in that area around the square patio that we're going to use with pavers or wood deck. Okay, so we need to find out how much area we need to fill in there, so we know how much that we need to buy at the store. All right, so we have a circle, all right, and then we have a square shape that's inscribed inside that circle. Remember, inscribed means that it's got the vertex, each vertex is on the circle, all right? And so we've measured from one side, one corner to the other corner is 6 meters, all right? That also represents the diameter of our circular shaped garden, all right? So we need to figure out, since all these are the same, we don't know how big they are, so we need to first figure out the length of each side, or the length of one side, and then we're just going to do length times width to find the area of the square shape, and then we're going to subtract that, because we don't want to fill that in with the grass, subtract that from the entire circle, and then that will give us just the shaded green area. All right, so let's go. So let's start off with the circle. All right, we'll do that in black. So area of the circle, again, pi r squared. All right, well, remember this is 6, so that means that our diameter is 6, so our radius is going to be half that, which is 3. So we're going to do the radius squared times pi. All right, so that's the area of the entire circle. All right, so that simplifies to 9 pi. I'm just going to leave it in terms of pi, and then we'll round it off in the calculator at the end. All right, so we'll just go with 9 pi for now. All right, now we're going to do the area of the square inside, okay? Now, they only give us the diagonal. We need to use that to figure it out. So remember, a square, all the sides are the same. So what have we created here? We've created an isosceles triangle, because I've got 2 sides the same, and then my hypotenuse is that diameter, or that diagonal going across. So I can use my rules of my right triangles. Since it's isosceles and it's right, that means that it's a 45, 45, 90. All right, so we know that if we do a 45, 45, 90, then we can use our special right triangles. If the hypotenuse is 6, all right, then in order to find the leg, I need to divide the hypotenuse by the square root of 2. Remember, the ratio is x times the square root of 2. So in order to go from hypotenuse to leg, I need to divide that by the square root of 2. So 6 divided by the square root of 2. Of course, I need to simplify it. I can't keep it like that. So 6 over the square root of 2. Remember, we're going to rationalize the denominator. That's when we multiply the top and bottom by the denominator to get rid of that radical on the bottom. So then we're going to multiply straight across. So I get 6 square roots of 2 over square root of 2 times square root of 2 is the square root of 4, which is equal to just 2. All right, and then we can simplify the numbers on the outside. So obviously 6 over 2 is equal to 3 over 1. So this simplifies to 3 square roots of 2. So that's the length of one of those sides there. Okay, now I can use that to find the area of the square region. Okay, so length times width, again, they're the same. So I'm just going to do 3 square roots of 2 times itself, or I'm just going to square it, okay, because they're all the same. All right, so let's go ahead and do that. So remember, square the outside and square the inside. So 3 squared is 9, and then square root of 2 squared is just 2. So what's the total area of the square? 9 times 2, or 18. Okay, so there's the area of our square, there's the area of our circle. Now we can go through and we can figure out the area of what's left if we take the square out of the circle. Okay, so do that in green. So I want to take the 9 pi from before, and then I want to subtract out 18 from that. All right, so let's bring in our calculator so we can go through and get the most accurate answer by rounding at the end. So I'm going to do 9 times, I'm going to hit the pi key, equals, so there's my area of my circle, and then I'm going to subtract the 18, which is the area of the square, and what I'm left with is going to be approximately 10.3 square meters. All right, so now I know how much area coverage I need in order to fill in that shaded area. Okay, so hopefully that helps. Tomorrow I'll get a worksheet assigned for you guys with some practice problems that you can work on Thursday. Don't forget, no school on Friday, and then I will post the solutions for that worksheet Monday morning. All right, so hope you have a great day, and we'll see you tomorrow.